I'll do this computer just in case I don't have enough cloud space. I don't pay for the big full Zoom. I pay for the cheap one. So I think I only get like some ridiculously small amount of cloud storage.
All right. Well, I'm looks like screen share is up and running fine on my end.
All right, cool.
So,
well, take it away whenever you're ready. We've got 5 now. That's a respectable number. It's not as much as I was hoping for, but you know, hopefully more will join in.
Cool. All right. So welcome everybody. This is I'm titling this session "Generative Design from Scratch." We're going to cover quite a bit though. I'm going to cover some of the new product line, both in terms of the desktop products as well as Dynamo. Not going to get into any of the cloud stuff just yet. But for those who don't know me, my name is Jacob Small. I'm a technical consultant focusing on generative design for Autodesk. I've been with Autodesk since 2017, very active in the Dynamo community. If you've ever been on the Dynamo BIM forums, you've probably seen a different picture of me, but a picture of me. Based out of Boston, Bachelor's of Architecture from Wentworth Institute of Technology all the way back in 2006, and been practiced right up until 2017 when I switched over to the technology side of things into Autodesk, where I got started as a technical account specialist is the new title, helping some really big firms adopt Autodesk technologies kind of at a super high level. So enough about me. Oh, if you want to follow me, feel free to look me up on Twitter at Jacob W. Small. I'm pretty active there, a little bit active on LinkedIn, not quite as much as I am on Twitter and also the Dynamo BIM forums.
Yeah,
I do have to.
I'm really wondering what's going to happen with Twitter's new owner.
Ooh, that's going to be an interesting one.
Yeah.
It's either going to be great or horrible. There's not going to be an in-between.
I think you're right. Yeah, go ahead. Sorry to interrupt. Yeah.
No problem. So I do have to show this big old wall of text during every one of the presentations that I give because I do work for Autodesk and we are a publicly traded company and the lawyers get very mad at me if I don't do this. So it's being recorded. We can confirm that I showed it and then I stay out of trouble. But it's a whole bunch of legal speak, which oddly enough can be broken down to a simple haiku along the lines of this. Shooting star falling, maybe a plane, Superman. Let's not buy just yet. So if I make any statements regarding coming product features or regarding stuff that the development team's working on that I know the Dynamo team has a fix in 2.14, which isn't tied into the product yet, you don't want to make your purchasing decisions based off that. You want to buy your software based on what it does today. All right. So what we're going to try and cover here, and my slide counts are a little bit different just because I wanted to make sure we had enough time to cover everything. And we actually got a lot more new toys than I thought. So we've gone through kind of our introduction stuff. We're going to get into our new toys. What's new in the 2023 product line and what's sort of new in Dynamo 2.13. And I say sort of new because Dynamo 2.13 has been out for a while now through Sandbox only though. And then from there, we're going to get into generative design isn't magic, which is all about, why you might want to get started with generative design, what it is, how the generative design process works, where you might want to use the tool, and then some common pitfalls before exposing the magic trick. We're going to show you how it all works. Everybody's seen the flashy videos of the Mars office and stuff like that, and they all look great, right? But nobody's ever taken the time to actually show people what it takes to actually get it done from scratch. So we're going to let you watch me saw somebody in half here. So we're going to talk about what the problem is. I've got a sample project that we're going to go through, which is applicable to pretty much everybody. And we are going to run this in the Dynamo Sandbox environment. So there are a couple sort of caveats to that. We're not going to be using as much of the Revit interaction nodes or baking anything into Revit or Civil 3D the way you might if you were in an actual project. But as Dynamo experts, which I believe I'm talking to mostly in the ChiNamo users group, we should be able to run with this stuff pretty well. We will also have time for questions throughout, and you can't see my other screen right now, but I've actually got the chat up. So if at any point I say something that isn't confusing, something that you're excited about, something you've got questions on, feel free to just put it in chat, or you can raise your hand. I've also got the participants tab up so I can see if there are any questions, and we can get to those kind of as we go. The more back and forth we have as I build this stuff up, the more you guys are going to get out of this, and the better it's going to be for everybody. I have more fun as well, which is actually why I'm here, right? Because this is fun.
Exactly.
So, all right. So on that note, any questions? Nothing in the chat? nothing coming up. Nobody's got any concerns over crazy stuff coming up in the product line. So we'll go ahead and get started. So let's talk about what new toys we have in the 2023 product line. We're going to start with Revit 2023. There is a lot out there. Measuring in 3D, picking a work plane to sort of move stuff around, duplicating materials and its assets, server paths for material textures and decals, tons of stuff for just general productivity enhancements. I'm not going to go all the way through the list. It is a massive amount, and the Revit product team, as well as some of my other colleagues, are sort of doing the rounds, showing off all the new stuff that is out there for just design productivity. And this, by the way, is just the first of 3 pages of new features. We've got some new simulation and analysis stuff for structural analysis, in particular around analytical models, right? Which is always the biggest pain, to have to go from your design authoring software, your sort of decision-making and documentation software, into your analytical tool set, bouncing it over to Robot or SAB or whatever you might be using, and back was a major time suck. Things are getting a lot better with that now. We've also got some electrical preliminary load analysis, which is really going to help out, and interactive solar studies, which I think a lot of people are going to have a lot of fun with. Personally, I prefer to do mine in Dynamo. I might be biased, but there we have it. Then on cloud stuff, we've got better data exchanges, fabrication data manager, technical preview, so that we can sort of tie content into our fabrication tools. Parameter service technical preview, that is actually my maybe second favorite, maybe favorite new feature outside of the Dynamo stuff, where we're going to be able to basically manage parameters a little bit better. Manage cloud models in the Revit home, which is a big thing. Last count for Revit cloud models, and non-destructive model rollback, which is another really big one, so that we can go back and open up a particular version without losing all the work that happened after that version. Some great interoperability fixes with format, CAD file improvements, IFC parameters, and design optimization improvements as well with Generative Design and Dynamo Player, method names for Generative Design, and the general user interface of Generative Design in 23. Now we get into our third page. This is all about documentation. Again, it seems like there's not much there, but there's actually a lot of stuff here. There's sort of little sort of quality of life improvements and things like that that really add up quick. So floor folding lines and split lines are going to be a little bit easier to work with, preserving area and room values when we're working in key schedules, filter by sheet within schedule, so you can put a schedule on a sheet and only see the stuff that's on that sheet. Yeah, exactly. Lots of thumbs up on that one. Displacing elements in 2D views, tag all displaced elements in 3D views, multi-leader tag enhancements, which was one of my favorite features from 2022. Rebar displacement representation changes, page order and PDF export and print output tool sets, and then a view and sheet API enhancements as well, which is something I'm really looking forward to getting into as well. So I mentioned I have a couple favorites, and they're sort of fighting for each other for which one we think is the most important. Right now, you could flip a coin and I'd let you know which one of these I think is my overall favorite, but it's either between server path textures and decals, so that we can now share common texture paths for all of our stuff, as opposed to sort of having to bounce back and forth and, oh, it's mapped to my desktop connector drive, not Paul's. Oh, now it's mapped to Paul's, not mine. And so I don't see anything. And we're constantly playing that tug of war. And there's all sorts of workarounds you can use around mapping drives and fake drive letters. And it can be forced to work, but now it's just going to work, which is really, really cool. And then the other piece is our technology preview. So this is, again, a preview, make no purchasing decisions, to create basically a library of parameters on the construction cloud, so that you no longer have to work about setting up the parameters per project. You can use the same ones, map them across, manage them consistently, which is going to be sort of a big sort of game changer for a lot of people, because now it means you can share your shared parameters file for this project for everybody else, and then everybody can kind of consistently work with that piece, as opposed to having to say, well, whose shared parameter are we using for that, door tag that we've customized, or the room tag that we've customized, or whatever it may be. So really looking forward to that. All right, on to the next product. Civil 3D. I am talking about Civil 3D, yes. And the reason I'm talking about Civil 3D, it's got a Dynamo tie-in. How can you not have talk about a product when it's got a Dynamo tie-in? So some of the big features and enhancements for design optimization and design productivity are listed here. Grading optimization enhancements, I think, is probably going to be my overall favorite, but we've got some changes to pressure networks, rail switches and crossings are added in, quarter solid property sets, quarter targeting efficiency, all sorts of great new features in terms of our general content. But again, my favorite piece is far and away the grading optimization. It's going to make a lot of our work with sites much easier, between the non-collinear segments returned into Civil 3D and being able to work with basically get your grading done faster and better without having to do the usual, like, well, how close are those contours really? What does that mean that we're actually changing? Now we've sort of removed some of that guessing game, which oddly enough is a lot of what we're going to talk about once we get a little bit further out today. Next piece, AutoCAD. Well, talked about Civil 3D, so I'm going to have to talk about AutoCAD as well. AutoCAD 23 now uses machine learning to help you learn about valuable tips and new features to work faster at the right time in the right context. So when you do stuff and it's recording those commands that you're sort of running, it's going to say, hey, you ran audit, purge, save, and you've done this like 6 times. Here's a macro to help you do that so you don't have to run 6 commands in a row. This is one of those features that, again, really new to this tool set, but it's one of those things that Autodesk, again, make no purchasing decisions. Thinking in the big picture, let's try and find out what stuff people have to do and help them build and implement tools so that they can do stuff much faster at that bigger scale. So I wouldn't be too surprised if we saw this or a similar sort of technology coming into Revit in a coming release.
Yes, please.
Yeah. Yes, big one, right? All right. Format Pro 2023, and this is the other sort of big piece here. So first up, design productivity. We've got some 2-point perspective changes, so we no longer are limited to that 3-point perspective, so your towers don't look like they're fading off into oblivion. We can also save and discard a little bit better. We've got some graphical improvements, a lot of performance enhancements, API plugin documentation, as well as some better capability to save scenes to Autodesk docs. Some better interoperability as well, which really I think is the bulk of where the benefit of Format is. It's much easier to take your Format content and get it into Revit, your Revit content, get it in the Format, make some changes, bring it back. We've also got the capability now to send a Revit preview, as well as the Dynamo 2.13 integration with new Dynamo Nodes and all sorts of other stuff too. So Format files now show up as a link CAD option within Revit. So when you go into your managed links, go into your CAD formats, hey, there's our format files. So now we can sort of manage that content much better than what we could before. This also sort of improves capabilities with 3D sketch workflows inside a format file, and as well as the edit in format button, which is pretty cool, so that you can sort of iterate and modify your conceptual designs much faster than you could before. It's also an updated 3D sketch workflow to sort of send a Revit as a CAD link, and then you can also send a Revit preview mode within Format Pro. So you're not sort of going to be forced to bake everything over in. You can just sort of get a quick snapshot of what this is going to look like, decide whether or not you want to work with it or not. Again, to sort of expand the design workflows between the interoperability, where it's much easier to make those conceptual changes in the format environment where you're looking at just pure sort of CAD and geometry manipulation as opposed to the larger tool set. We've also got some new Dynamo nodes. Sorry that the image is sort of underneath or over the text right there, where we can now sort of control the faceting of curves and surfaces attached to the format, where if you want to sort of bring format geometry from Dynamo down into format, you can choose exactly how complex you want to bring that content over. It can either be really faceted or less so, obviously less so. It's going to be a heavier model. We've got more faces to deal with, right? We've also got capability to group sort of different sets of geometry to sort of manage that content a little bit better. So again, it's better control and display of the surfaces that we're bringing from Dynamo down into format. And then last but not least, we've added non-geometrical outcomes into our format data. So if you want to take your massing and sort of run a Dynamo graph around like what should the optimal height be for these levels, optimize that, put that out to Excel, we can now do that, right? You don't need to send a format node in order to get the data to actually, or the Dynamo graph to actually expose inside of the format environment, whereas before you had to send fake geometry and then delete the geometry after the fact, and that upset format in Dynamo. None of that's an issue anymore. We can just get to the data that Dynamo can mine from our content. And that's the end of sort of the desktop stuff. There's some other changes around robots, in particular with the Dynamo integration, which is now a formal integration, Advanced Steel, and some of our other product lines, but wanted to sort of keep it to the more popular Dynamo integrations for now. And now into Dynamo 2.13. Tons of changes in Dynamo 2.13. In particular, you'll notice there's a massive visual refresh. Dynamo itself looks very, very different from what we had before. So we've got a styled workspace tab where you can sort of see stuff that looks a little bit more modern and sort of stylized as you might expect it to. We've also restyled the notification window and icon surfaces there over at number 2. So little changes like this, but to me, the biggest change here is when you look over at the actual nodes. Those nodes are going to be very, very different looking than what we saw before. Just as a heads up, when you open your Dynamo 2.12 or prior to 2.0 or even 1.0 or, you know, heaven help us, the yellow node days is 0.6. These nodes in 2.13 are larger. Everything got bigger. Right, and this includes the library. If we go back to that previous view, the library has a lot more padding than what I had before. The nodes as well got bigger, and this was sort of an accessibility change that the team made to make it easier for people with visual impairments to sort of be able to work with. Mixed reviews on how well it's working, but because things are bigger, your nodes from prior graphs may be literally stacked on top of each other. I did post something to the Dynamo BIM forum. You should look over at my actual topics. It should be the most recent topic. If you have old graphs you want to upgrade, go ahead and open that up, and it will basically take this spacing for all where your nodes are on canvas and just scale them up by whatever values you give them. I've got them set to a decent setting right now, but you might want to change that. And it'll process an entire directory and give you a new directory with all your graphs ready for 2.13 days. Some changes in terms of how we provide context with clarity. That's what we're sort of getting at with all the number 1. Anytime a node gets renamed, you can now see we've got a little blue dot. Nodes that are missing an input get a red line next to the input that it sort of needs to be filled out. Node that has a valid input shows up like this. We've also got some additional changes to wires. Oh, we're going to get to wires in a few. Visual refresh as well on alerts. So you're going to sort of be able to expand out your alerts. You can actually show all your alerts as well as dismiss alerts. Once dismissed, alerts aren't going to show up as warnings. So if you've got that one node that produces a warning and it's running through Dynamo Player, you know, if somebody's got a room that's unplaced or something like that, and you know what, I don't care that you couldn't recenter the unplaced room, suppress that warning. You can go ahead and do that now, which is pretty cool by just hitting that dismiss. That's going to keep that from showing up. You can go back and review those dismissed alerts. So if something gets popped up after the fact, or you want to go back and edit that content, you can always do that later. We've also got some big changes to groups. This might be my favorite feature of 2.13. It's either this or one of the coming slides. So the great thing with groups now, we can nest groups inside of groups, which is super cool. We've also got some great group style nodes so we can sort of manage stuff. The other thing that's really nice about this is we can actually take nodes and just drag them and drop them into a group, and it's just going to get added to the group, which is super cool. The biggest, coolest feature of all of this, though, in my opinion, is this. We can now collapse all of a group down to just give us what nodes go in or what inputs come in, and we see inputs for those, and what inputs go out of the group, and we see outputs for those. This means our big, massive graph can be very, very compacted and sort of edited up and simplified in a drastic way, which if you're like me and you've seen some of those really massive graphs on the Dynamo forums that just make you want to pull your hair out, that's no longer so much visual clutter, right? We can take that massive collection of nodes and compact them down and really get down to just what the data wants to be. We've also made some changes to the name or the group sort of heading is what they're calling it. If we go back to this previous view, we've got a big title input and then the detailed description. So we don't have to worry about miles of text up in that title input anymore. Just what is it doing? Simple description followed by the mile of text underneath, which is the other big piece. And then last but not least, we've got some changes to wires. You can now pin wires. So if you want to move them around on canvas, get them into a different position so you don't have to worry about a wire running under a node, you can do that. You can also hide wires by right-clicking and saying hide wires, which is pretty cool. And then the last big piece, if you right-click on a wire, you can actually insert right in here. If you hit that little eyeball, it's going to insert a watch node in the middle of the wire, which is pretty cool. So you don't have to worry about sort of adding in watch nodes or trying to understand what data is coming in, scroll for a mile and a half to get back to the previous node, right? And then get to that content. You can just click on the wire where you get the little plus sign, add in the watch node and go from there, which is really nice.
What do you, the hide wire, that seems a little like, how would you know where it's connected?
So you don't until you select the node. I had mixed feelings on this until I actually got to play around with it. Once the node is selected, so you can see this node on the right here has been selected, you sort of see that faint outline of the wire there, which is a hidden wire. This wire is not hidden, and it's a little bit clearer. The big reason for this, again, if you think of some of those really big graphs, like generative design graphs and stuff like that, right? You want all your inputs off to the left, and the action might be happening like the last node on canvas. And so either you've got like 7 sets of pins to move that wire along the base before you get it up where you want it, or maybe in an older version, you were using an object.identity to just pass the data in out the other side and just route those wires. With this, you don't have to worry so much about that. You can just wire it up and then just hide the clutter of the wire and know that it's coming from somewhere else, which is kind of nice. Personally, I will probably, instead of directly connect it in, I will probably use a code block and just label what that wire is for those large inputs once we start to really get into that, or maybe use a watch node that's been renamed or something along those lines. Just, I don't like having to scroll or pan, I guess I should say.
Yeah. Okay, cool.
So some other big changes, a lot of people are going to be really happy about this. First one, search is 2.3 to 4.3 times as fast as what we had in previous versions. Yes, again, big thumbs up from everybody. This is really, really noticeable as it interacts with every character that's typed. It could still get faster, in my opinion. It still may get faster, make no purchasing decisions, but it's going to be sort of a big noticeable change for a lot of users. We've also removed a lot of memory bottlenecks to ensure sort of linear scaling as graphs grow in terms of the amount of data that they work with, which should help everybody out a good amount. We removed the ability to have a polycurve representational wires to sort of boost the performance of Dynamo. So basically they just modify the way polycurves displayed. We optimize sweep to sort of pass or optimize the sweep to do a quick pass of garbage collection. So we're seeing 4 times faster to 50 times faster for memory allocation. So data gets pushed into memory much faster than it was before. Made some tessellation improvements for rendering performance, so things show up faster. Stop unnecessarily installing package dependencies that we don't necessarily need. If you had a newer version of Clockwork and somebody installed Bakery on that system, it goes to try and download the old version. Like, nope, fix that. Node autocomplete was set to work with nodes for multiple output ports. Previously was just for single output nodes. We also fixed the menu for access keys, so I can once again go back to doing my hit the Alt button EAT to align to the top and stop using Monocle. As great as Monocle is, I'm a keyboard guy. I like my keyboard shortcuts. And then we also got to put in some APIs to get the file size of a path and sort of select up and downstream nodes from a selection within the Dynamo interface for add-in developers. Any questions on any of the new stuff? We're 28 minutes in, so I'm doing pretty good for time so far.
That's all fantastic, and I'm super impressed. I thought I talked fast, but man, you
I go quick.
okay, you got through that, and you took breaths in between. I'm not sure where, but man, well done.
Thanks. All right, so let's get into the generative design stuff. What everybody's really here for, the fun stuff. Let's watch a cool demo. So the first piece, the golden rule of generative design: one does not simply walk into generative design despite what the movies may say. And by movies, yes, I'm referring to the lovely marketing department, right? Everybody's seen that really impressive video, and I'm not knocking anybody's work here, but the Mars graph, right, for laying out that entire the Autodesk Mars office, super impressive. It does some amazing stuff. it took a lot of work to make that happen. And if you want to implement generative design, it's going to take work. Nobody's going to just hand it to you on a silver platter. And after you get it set up, it's going to take work to maintain it as well. So don't think that this is sort of an easy button. It's not. It's a different way to approach design, and it is going to change the way that people use design over time, but it's not going to make all the problems just go away. So why do we want to get into generative design if it's not easy? Well, we've got to get better at making decisions. And the reason for this more is inevitable, right? We need to build, in order to meet the demand, 1,000 buildings a day in between now and the year 2050. That is a lot of new construction, and we are nowhere near that pace, and we are not putting enough technicians into the field to get there, right? Beyond that, we've got increased demand from clients. How many clients used to ask for a rendering with every single interior perspective? How many clients have asked for, oh, can you show me the view from that window, from this window, from that window, from this, from that? The amount of sort of content that we produce is going way, way up as a result. We've also got some new challenges that the prior generations never had to worry about. Embodied carbon content, if you brought that up to Corbusier, he would have laughed at you, right? What is this thing that you're speaking of? I don't get it, right? Design is different. The challenges we face are different. And so we have to move faster. And most importantly, for the business perspective, the fees or time that we're given to perform these tasks are not moving as fast as those requests and the new projects are coming in. You're being asked to do more in less time. And as a result, the previous method of guess, before, miss, darn it, no longer applies. It's not feasible to say, where should the entry to the building be? Maybe here, maybe there. And then 6 months later, after you're through DD, through SD, into CDs, you're like, you know what? If we just shifted the lobby around over to this side and then put the entry desk here or the reception desk here, this would be a lot better a design. It's too late to do that now, right? So that's sort of why I get into generative design. What is generative design? Well, simply put, it's the next evolution in our design technology, right? We went from way, way, way back in the day to, you know, I think Clifton Harness tweeted it out the other day, you know, 1980s graphite everywhere, you know, 1960s graphite everywhere, 1980s AutoCAD everywhere, 2000 Revit everywhere, right? 2020 generate, right? Let the robots start to build the content, right? And that's really where we're at. And we've gotten to that point with visual programming, but we're not yet at the point where we partnered with the machine to sort of document the design, but we haven't partnered with the machine to decide what should be, right? This act of designing a building, it's making a decision for what should be and recording what that decision should be, right? And there's lots of reasons to make a decision. Some of them are just intuition, and intuition's good. We shouldn't be knocking it, right? But some of them are very logically driven. And that's really where generative design sort of fits in, to help you make those logically driven decisions in the most optimal way possible. So how does it all work? Well, we are all familiar with Dynamo for Revit, I'm assuming. The intent of generative design is you can take some Revit information, take some other sources of sort of decisions, feed them into Dynamo for Revit, and then feed the Dynamo for Revit graph into generative design, let it spit out an outcome, and get that content back into Revit, right? It looks like a fairly simple diagram in the beginning, but it actually gets pretty complex. The key piece is to understand that generative design is not this. You're not just going to go into generative design and then get data out in Revit, right? You're going to have to take some time to sort of prep the tool to build that Dynamo graph that goes the back end. Good question in the chat. Is this powered by an actual generative AI algorithm on the back end? So there's actually running a NSGA2 algorithm on the back end. So it is a genetic algorithm to just sort of find that optimal piece by running multiple sort of generations of a population, taking the top n percentage of that and using that to perform, inform the next generation that is run. And you do that a few times over. And we'll get to a bit more of a in-depth explanation on how that works once we get into the actual product in a few minutes here. So understanding that this is how this process all works, we already know sort of how to set up a number slider in Dynamo because we're Dynamo experts. And we already know how to move Revit data into Dynamo, like select model element, get parameter value by name, so on and so forth. What we don't know is how to move from Dynamo for Revit into generative design, or Dynamo really into generative design. Oh yes, you don't necessarily have to have Revit. You could be running this off Civil 3D. You could be running this off Format. You could be running this off not. Actually, I'm going to be doing the entire demo today in Dynamo Sandbox as opposed to Dynamo for Revit, just so that we've got a little bit more of a variety of applications to sort of talk about. All right, so how do we get that content into generative design? Well, there's a process. We're going to go up into Dynamo. We're going to say open generative design tools, and we're going to say export for generative design. And then you basically fill out some information. This is a screenshot from an AU presentation I gave about 2 years back for my generative design at Hogwarts session, where we were exporting out the layout of the magical creatures, OWL. So that explains that description that we've got there. Once you've basically put that information in, decide if you want to attach an image, you're going to go ahead and hit that export button, and then it's going to send that content out to generative design. You'll get a little message like this. Now, depending on which version of generative design you're using, you might see a slightly different layout than this. I'm showing one of the older builds, but the gist of it is all still there. Once you understand this, you're going to understand those other options as well. Once you export it out, you should be able to select that study in generative design. So now we understand that bit. What's this next bit? What actually happens when we get into generative design? Well, generative design, effectively, it's a server that's going to spin up an instance of Dynamo by sending to a headless version of Dynamo that you don't see, a copy of your Dynamo graph, and then a series of input values. And that all gets sent out to Dynamo Sandbox. So we're in Sandbox. We don't have any access to the Revit API, the Civil 3D API, the Format API, the AutoCAD API. So there are some limits to kind of what we have to do in order to work with that data. But once we get that data in, that headless version of Dynamo is going to open up our graph. It's going to set our input values. It's going to get results, and it's going to send those results back to generative design. It's not going to do this once at a time. No, generative design is going to do this 6 times concurrently. That's right. We're going to run 6 instances of Dynamo side by side on top of the server that's driving them all and managing all the data that's coming out and in. That means your task manager is going to look something like this. That is a lot of generative design service right there. Then we've got all the generative design sub-processes and these REST Dynamo core. These are the actual instances of Dynamo that are spun up without the head. Eventually, those instances get shut down. You see them go, sort of gray out like that. Once that happens, those processes stop, and then we get new ones. That one down here that you see is because I wasn't fast enough to take the screenshot before this one died and that one spun up. So once we get those results back, we can then individually choose of those results that we've received from the top performing, which was the best option, take that best option, select that option, and then have generative design send to a copy of Dynamo for Revit instead of Dynamo Sandbox, or Dynamo for Civil, or whatever version of Dynamo we might want to work in, back out and record that data back in by making elements in Revit, objects in Civil 3D, or saving an Excel file or generating an IFC, whatever sort of decision process you might want to make. So where do we want to?
If only there was some sort of automated way to get that screen capture.
Yes, if only.
If only. Please continue.
No problem. So where does this tool make sense to use? We've got a lot of decisions that we have to make. What's the best spot to use this tool? Well, it's gonna make sense to use this tool where the decision isn't obvious, right? So case in point, what's the best spot on the site to put the building, right? We've got a wide open brownfield. What's the best spot to put it? What's the best rotation of the building? Right? And we can sort of evaluate those things against, the grade, the topography, the landscape, the trees, the woods, the drainage, the sun, right? All those sort of aspects can inform something like that. And it's not necessarily clear to a human instantly by just saying, hey, here's a site plan, what's the best spot, right? So if it's not instantly clear, yeah, that's a great spot. Another great spot is when we've got sort of conflicting goals. I was recently working for a company that was trying to sort of optimize the layout of a bunch of equipment. And these equipments have to sort of have pipes that connect A to B and B to C and C to A. And you know, there's actually like 30 different pieces of equipment and all these different pipes running back and forth, and different types of pipes too. Some are stainless, some are carbon steel, some are PVC. And each of these have a different cost and different diameters. And depending on how much that particular pipe might cost based on what it is that they're trying to run, you're going to have different impacts. What's the best way to lay out all the equipment? Using one consistent pipe rack to sort of ensure that things are as inexpensive as possible. Well, if I start equipment A here that has a lot of stainless and all the stainless stuff is here, that's going to score really well. But that means for stainless cost, but the carbon steel cost is going to be really big because all the carbon steel stuff's over here, right? Well, if I put the A over here that has all the connections, then the stainless cost is going to be high. If I put it somewhere in between, that makes sense, but where? Generative design is very, very good at solving those problems where you start to have this push and pull to make this piece better, that piece is going to be worse. Somewhere in between is that ideal position. Where you don't want to use generative design is exactly where it makes the least amount of sense. We don't have a way to evaluate this. We don't know what is this building beautiful is this good architecture? That's not necessarily clear right away. But the layout of the rooms in the house, yeah, absolutely, why not? The exact positioning on site, sure, right? So there's lots of ways for this. And the key piece here is it's not going to remove your capability to make decisions as a designer. It's just going to help you make those decisions in a sort of more guided way. So let's talk about some common pitfalls. The first one, unrealistic expectations. And I tried to put the kibosh on this really early in the presentation today, right? Where I was like, yeah, it's not going to be easy, because it's not. You're going to have to spend some time to make this happen, right? You're going to have to learn how to use this new technology in the right way and time to implement it. There's also a lot of questions over uncertainty of outcomes. If you don't know how to decide that this is better than that, or what it is that you're evaluating for, it's not yet time to do generative. You should probably go back and have a conversation with the client about what's important rather than just diving in. If you don't have a process, or you're just not sure what the process is for making decisions in your design, it's not yet time to dive in. Where does the reception desk go and why did you put it there? If you can't decide that, then there's no intention behind generative design. It's, you know, throwing darts at a dartboard. You might as well let your intuition continue to guide you. If you have a lack of experience with the underlying technology, if you've never used Dynamo before, it's not time to get into generative design. You've got to be able to understand how to build your own graphs in a way that makes sense. If you try to boil the ocean, you're going to fail. There's just too much water there, right? So try and bite off a small problem rather than trying to say, yeah, we're going to use generative design and get the entire building. Nope, one thing at a time. And then last but not least, a single point of failure. If there's one person in the office who can make use of this technology, when that person leaves, you will not be able to use this technology anymore. And I say when, not if, because every time I've seen that person leaves, and then I would get the phone call, we don't know how to use this thing that's really important to this project. Can you help us out? Right? So make sure that it's multiple people sort of understand the process, understand what goes into it, document that process, document what's going into it to make sure things are moving consistently. Any questions on anything I just showed before we get into the fun part of the demo?
Hey, Jacob.
Hey, Dana.
Awesome presentation, as always.
Good to see you. Good to see you.
Likewise.
All right. Nothing, on we go. Let's talk about sawing somebody in half. So we're going to peel back the curtain here a little bit. The design brief. Customer wants 2 cabins totaling, instead of totally, there's a typo, I gotta love those, around 1,800 square feet on a wooded lot. The cabin should have ample circulation between them. They want to feel secluded, so we don't put them right on top of each other. The shape, totally undetermined, but we want to try and keep it to 2 sort of simple rectilinear gables, just because they're big on prefabrication. Site's going to be 2D flat, and all points are equally buildable, so we don't have to worry about, oh, we can't put that there. put it anywhere on site you might like. And we want to maintain as many trees as possible to keep that natural sort of setting. So we've got some goals that I listed out there, right? Secluded, so separation between, close to 900 square feet per cabin, giving us about 1,800 square feet total, and minimizing the amount of trees, right? Customers come to you with problems like this every single day. Well, hopefully every single day, not like once every 10 years. You guys hopefully have more projects going on than that. But when they do, how do we sort of evaluate those pieces, right? We will write that stuff down, we listen and we understand and sort of document what it is that they're looking to get out of the project. So let's dive over into that live demo. I've got a site, right? I've built this site purely in Dynamo using just sort of numbers, right? So what you can see here is I've got, yeah, of course. Why would I use another tool set? I'm the Dynamo guy. So I've got a code block here that is point by coordinates, and then a list of X values and a list of Y values. This is basically what your surveyor is going to do when they go and they pull up a list of trees. There's a tree here. We've got a point, its coordinates in X, Y location, maybe Z if they're smart about it. And then that content gets brought over to create blocks in Civil 3D, right? I'm just cutting out the middleman. And then I've got another piece, which is code block down here, which is going to generate a series of points. And then I'm going to use those points to generate a polycurve, just like I had a site plan. Once we've got those two pieces sort of set up, we're ready to get going. So you might probably aren't generating your points in your site the way that I am. You're probably using a select model elements or all elements of type or all objects of type if you're in Civil 3D. Once you've got those two pieces, we can start to get to work on generative design. Now, because I've done some work here in sort of serializing some stuff manually into the graph, this step wouldn't have to be performed, but I want to make sure we understand it. I mentioned before that we're in Dynamo Sandbox when we send stuff to generative design, so we have no access to the Revit API. Notice no Revit over here, no AutoCAD over here, no Civil 3D over here, no Formit, Dynamo Core, and that's it. So if your data came from somewhere else, you can't tell Dynamo to go grab that data again. So what we have to do is under generative design, we have to go into our data and put in a remember node. Remember node is my favorite node in all of Dynamo because it means I can take anything, put it into this node, run my graph. Right now it says null, right? Run my graph, and now I have a whole bunch of data. I'm going to do something crazy. I'm going to disconnect this, and then I'm going to hit run again. That data is remembered. The content does not go away. What
like
does this mean to
the memory button on the old school calculator?
Yes, it's the memory button on the old school calculator, only it's better than that. I can now take this graph and I can send this graph to you, Paul, and to Dana, and to anybody else on the project team. And guess what they're going to have in this graph, even if I did something crazy.
Whoa.
The data does not go away. I don't have
Even
to
if you
worry about
save it, close it, reopen it,
the
send
one
it to
thing
me,
is
I open it.
I have to save it first. Once I save it, I can do anything with it, right? If I did something really silly and said null and wired that in and then ran my graph again,
Now you ruined it.
It will remember that.
Yeah.
I actually can't use null because it's used to seeing null. That was a mistake on my end. If it sees null, it keeps what's in there. But if I send any other data to that, it's going to remember the new data as opposed to the previous data. So we're going to hit undo a few times. There we go. And then I'm going to remember my points. These are all my trees on my site. And then I'm going to remember my site. This is my site boundaries. Then I'm going to disconnect these two nodes. I'm going to take these and I'm going to, I got to do it individually. Turn off the preview and then freeze them. And this is going to keep them from executing just to save us a little bit of time so Dynamo can just work with the data that it knows about, these two, instead of having to build new data from scratch. So we've remembered our data. We could now send this out to generative design. And because generative design has this content remembered, it wouldn't have to worry about selecting Civil 3D content, Revit content, or any other content.
So is
All right.
that remember thing only in Sandbox, or is that in regular Dynamo for Revit too?
It's in Dynamo for Revit as well as in Dynamo for Civil, as long as you have generative design installed. The way to get that,
Okay.
install Revit, and make sure your generative design comes in with Revit. It should in 2023, the newer 2022 build. Install the update. If not, once you've got that content there, you can take that package and point your generative or your other Dynamos to that. So Civil 3D can point at that generative design package, Dynamo Sandbox, Dynamo Format, Dynamo for Alias, for Fusion, for whatever it may be that you want to work with.
Cool.
All right, so now that we've got these two pieces, it's time to get to work. We want to build two cabins. I'm going to actually temporarily just hide these pieces. And we said we want those cabins to be pretty simple rectangles. So let's start with a rectangle. We're going to use a rectangle by width and length node. This takes an X input. We're going to use a number slider and a Y input. I'm going to configure these number sliders to have a minimum dimension of 15 and 45. And we're going to set it up to step by 1. I'm going to rename this number slider to building a width. And we'll copy that down, and I'm going to do building a length. Wire these two pieces in. And I'm going to live dangerously. We're going to go into automatic run mode for the remainder of the demo. All right, so this generates a quick rectangle, and I can scale up that rectangle. And just like with Dynamo Player, if I right click on that node and say is input, we can mark those two nodes as an input. Right, so we've got our width and length input node. If I were to send this out to Dynamo Player, Dynamo would be able to sort of, Dynamo Player would allow me to adjust this. It's the same thing in Dynamo Sandbox. That is input flag is how generative design knows this is something we can adjust. Good question in the chat. Have I tried manipulating survey files like RW5 or FBK? I have not. I have, however, worked with point cloud files. So PTS files, you can actually read those in as text files, generate all the points from them. And if you really wanted to get crazy, you could actually generate VASA models from those as well, which is pretty cool. Then we can get into voxel analysis of entire sites. I've got some stuff up on my Twitter of, you know, people dancing in a building and what shadows they would be casting in a point cloud environment, which was pretty cool. So great question, by the way, Ricardo.
We totally need to talk later. Okay.
Cool. So we've now got our rectangle, but we want something that's a little bit more than that. So let's make a second rectangle with a second set of inputs. I probably should have just copied them all at once. And then I'm going to call this building a addition width. And I'm just going to copy that addition because guess where that's going? Right in here. So now I've got two rectangles, right? And this addition should probably be a little bit smaller than that. So let's go 5 and 25. You know what? I like to keep numbers sort of common sense. So I'm actually going to change this to 10 and 50. So our addition will be at most half the size of the main building, 5 and 25. And we'll change the size on this. And you can see I've got two rectangles, but that's not an addition, right? What we need to do is we need to first geometry.translate, move this piece over on the x-axis by x divided by 2. I'm going to turn off the preview on this. And what I did with that is this is now sort of, if I zoom in on it, right at my origin. And because I have another curve, another rectangle here, we can do a curve dot coordinate system at parameter and take our curve, which is our rectangle, and then another number slider ranging from 0 to 1, stepping by 0.01. Rename this addition control points, wire it in. Here we go. And I can move this coordinate system around. Notice the colors happen to align to the colors of my global axes. I'm going to go ahead and hide everything except for this. And then we're going to use a geometry.transform node, which takes a geometry. Okay, I've got a addition down here and a coordinate system. I got a coordinate system up there. And now as I adjust this control point, I'm able to move my addition around my other box. And I can adjust my building width or length, or my addition width or length to get different shapes. All right, so now with these two, I'm going to go ahead and use the combinifier from Monocle. We'll hide this. You can see I now have one list with my two objects, surface by patch to get a nice little surface out of each rectangle, and then surface by union to join the two surfaces into a single surface. Now that I've got a surface, I can do surface things to it, right? So surfaces have stuff like an area. And we happen to know that I was looking for about 900 square feet. My building's a little small right now, right? That's fine. We're going to let generative design do its exploration a little bit later. All right, so now we've got a single surface, but I wanted two buildings, right? I didn't want just one. Well, copy that over. I'm just going to make sure that first this was marked as an input. It was not my addition control point. And I'm also going to rename this because I've got two of these. Building A, whoop, I missed the space. And then I need a building B. And make sure that is marked as an input. These are already inputs, but I do need to rename them. Portugal is a long way out there. Ricardo, congrats. I think you might be actually, I'm in Stockholm at the moment.
Are you?
Yeah.
Oh,
I was originally going to be back in Boston area, but when we scheduled this, but I moved my flight to get some extra time with my fiance. So
nice.
yeah, I was not complaining about a late night if it meant another week here, you know?
Glad I could help.
Yeah. All right. So we're going to take this. I'm doing a little bit of node cleanup. You may be noticing I keep sort of freezing like that. I'm used to notice the E is underlined here. I'm trying to do my shortcut, but since I'm in Dynamo 2.12, this shortcut actually got broken. So I have to sort of click in order to do these pieces now. The Monocle shortcut is pretty nice, but every once in a while it sort of gets stuff backwards. But now that I have these two pieces, I can combine them into one list, and I've got two different buildings, and I can adjust those buildings as desired, right? But I've got a problem. The buildings are kind of in the middle of, you know, nowhere relative to my site, right? So let's go ahead and turn on the preview on this. Go. I'm going to take these pieces and I'm going to pull them off to the left. Now, I want to be able to move these around. So how do we sort of move geometry? We've already seen it once, coordinate system. So if I create a surface by patch, we can quickly create a surface from my site. I'm going to just hide that geometry preview because it's going to get in my way. Then I can do a surface dot coordinate system at parameter to take my surface, and this needs a U parameter. We're going to name this building AU and a V parameter. Yeah, AU. And that needs to go from 0 to 1, and we're going to step up by 0.01 once again. And a building AV. AV, there we go.
AV, AU.
0.01 as my step. So now I can adjust this. And if I wire that U and that V in, there we go. I can now, you can see the coordinate system just sort of floating out there as that sort of pinkish looking dot. And as I pick random spots within my slider, it moves around. But I need 2 of those, right? So we're going to go ahead and duplicate these. Actually, I'm gonna cheat. We're gonna set this to 360, and I'm gonna step it by 1, and then we're going to rename it to building A rotation, because I want to be able to rotate those buildings as well, right? I mean, if we had a crazy sort of building, we'd want to be able to sort of adjust it relative to, I don't know, the sun, or maybe so the addition sort of magically fits between 2 trees. So how do we rotate a coordinate system? I'm going to go into geometry. I'm going to look for abstract. I've got a coordinate system. What can we do to create a coordinate system? We've got that, but modify. Well, we can rotate about an origin or rotate about a plane. I'm going to go with plane here. And the reason I go with plane is because I can quickly pull the XY plane from another coordinate system. And then I don't have to worry about the other rotation option requires an origin and an axis. That's 2 hits in my memory. I want to just have 1. So we can put that in there, hide all this geometry preview, bring my rotation parameter over. And now I can adjust this value. And hey, look at that. That coordinate system is rotating as I click it around. Right? But I need 2 buildings. So we're going to copy this. We're going to rename this BU, BV, and building rotation. Now, let's just make sure these are all marked as input before I get too far ahead of myself. Cost myself some extra clicks there. And now I'm going to take my U values, combinifier, and my V values, combinifier, and my rotations. Shout out to John Pearson if he ever watches this video, or if he's in the room, I don't know.
I should have sent him an email. I'm sorry about that.
Oh, no problem.
Yeah.
So you can see I've got 2 coordinate systems, right? And I've happen to have 2 sets of buildings. So geometry.transform once again. With this geometry, my 2 different geometries, I don't need to worry about lacing because I got 2 different coordinate systems. So now I can adjust the size of any one of these, adjust the rotation of any one of these, and adjust the location of any one of these. We've got a full parametric model that we built. All right, so we'll pull these pieces over here just to keep all my inputs together.
You're using we pretty generously there.
Well, hopefully people can come and follow along from the recording if they want to.
Yeah.
I have faith that you guys know what you're doing.
Yeah.
You've got some good leadership in the area. All right, so now with those pieces, we can start to say, is this good design, right? Because the computer, knowing full well that we've got this genetic algorithm that's just going to be able to just quickly adjust these values and return different results, we need to be able to sort of tell the computer, this is good, that is bad, right? So how do we do that? Well, what did we have for goals? You remember the first one was
keep the trees.
Distance.
Oh, distance.
Skip the trees.
Yep.
Sure. We'll start with skip the trees.
Yeah.
Geometry dot does intersect. This is a great node. It's just going to return a quick true or false value for some geometry. Now I've got a list of buildings, right? And if I have to test every building against every tree, that's 2 tests. But really, I want to test every tree against all the buildings, right? And I used previously this surface by union. It's not going to work here, but what I can use is a poly surface by joined surfaces. Bit of a misnomer, because when I wire this in, I get a single poly surface, even though those 2 pieces don't touch. I have 2 buildings today. What if I had 100 buildings? That's 100 tests against a lot of trees if I've got 100 buildings. Now instead I have one test against a lot of trees. So much, much faster. So now we can take our other as our geometry, and then here, let's go ahead and preview those trees, right? You can see we've got some intersections. So we should see some true values somewhere in this. Hey, there we go. There's one. There's two. We could also get a little bit more sort of particular. How close can I really put a building to a tree? If I miss that thing by a ½ inch, is that tree going to last? No. Let's use instead a geometry.distance2. Helps if you spell right. And once again, we can take all of our trees and test them against the combined sum of all of the buildings. And now I can ask, is that value less than 10? This is in a code block, right? And I can get really fancy. I can say, if it's less than 10, question mark means I'm in an if statement. I'm going to return a value of, I don't know, 10. Otherwise, return a value of 0.
Has that always been like that? The question mark thing?
It has. That is the shortcut annotation for writing an if statement in Design Script.
Wow. I have a lot to learn.
I'm still learning, so don't stress it too much.
Yeah.
Now with a series of values, we can do a quick sum of all of those values and return a score of 50. This is my tree score. We've built our first output. We're going to right click on this, mark it as an output, rename this node, tree score. All right, so there's the first piece. Next piece, how close is building A to building B? We've got our distance 2. We've got our 2 buildings. I'm going to go ahead and I'm going to hide all of these. Actually, let's do this. Geometry color by geometry color. Dana, I'm going to pick on you. Can you pick a color for me? What do we feel like? Or Paul, if you're
I could unmute. How about blue? Go to the top right.
top right.
Make it easy on you.
All right. Can you give me one more color? Because I've got 2 buildings, right?
We'll go
Stay
bottom
away.
right.
Bottom right, that green. Let's actually stay away from the greens here, because
Stay away
I'm
from the
going to
green.
do something fun with the trees here in a minute.
Oh.
All right, go one to the right of that one. Go purple, yeah?
One to the this
Oh.
one.
Yeah, that one. Where your mouse was is where I went.
All right, so we're going to take these 2 pieces, combine them into a list, wire that in as my color, and then take my geometry as our 2 buildings. Now I've got colored buildings. I could, instead of referring to it as building A and building B, we could refer to it as building blue and building violet, right? So this is going to make it easier for us to display that content. And then I'm going to also do this. And I'm going to come back up here one more time. I'm going to copy this node. And then instead of returning 10, we're just going to, or those values, I'm going to clear out that if statement. And this is going to give me a true false value. We'll filter by bool mask. This will be our mask. This is our list. Turn off the preview on that, turn off the preview on this. And we'll take the copy of these. And first color is going to be red. Second color is going to be green.
Mm-hmm. Huh.
Makes it a little bit easier to see which trees are going to get chopped down by doing this construction, because it's within 10 units of the building. All right. So then I started to talk about this one before. We talked about the distance between. So I'm going to pull the first item out of the list and then the second item out of the list. Using a code block, I could use a list.deconstruct. I could use a couple other built-in nodes, but with these 2 pieces, I can now get a separation between the 2 buildings. I always use a math.sum node right before in case for some reason I was to return some kind of crazy nested list. And then I put a watch node on canvas. I always use watch nodes as my output. I never, like, I could just right click on this, mark it as an output and rename it, but I like to make sure that I use a watch node because I like to group stuff together. All right, now
Hey, you
you've
should
got to have,
save.
I should save. That's a great call. Control
Actually,
S just
didn't
got
even
hit.
realize that other nodes could be outputs because I only use watch nodes. Like
Yeah,
I feel like
do
that's
that either.
all I teach. I'm like, nope, this is the only output node that you can use.
Yep.
So good call there.
Yeah, I've had some discussions over that inside the factory in my days because I think things should be one way, and people are like, no, we made it this way for a reason. It's like, yeah, somebody asked for it, but they didn't know what they were asking for.
Yeah, don't get me
Anyway.
started. Yeah.
All right, so we've got our first two scores. The next piece, we wanted it about 900 square feet each, right? Surface dot area. Helps if you spell it right. All right, so we're going to take each one of those pieces, and that area is nowhere near 900, but math.sum. The request wasn't actually for 900 square feet per cabin. It was for 1,800 square feet total. Size score. And then I've got one more piece. Does anybody see a problem with the design? Anybody? Bueller?
Outside of the property line?
That's a big problem. We can't build our building on the neighbor's lot.
Yeah.
All right. Geometry dot intersect. And I'm going to take these geometries and I'm going to intersect them with the overall surface for the site. And I've got a building that's completely off the site, right? We're then going to flatten this list. As a result of that building not being on the site, I've got an empty list. Flatten this list, hide all that geometry preview. There we go. We've got a single surface, surface dot area. Math.sum. (231 units) equals. And I'm not going to use this one. I want exact. I don't want the new sort of equals node. I want the real equals node. Test, question mark, 1,000 if false. That's a really bad score if the building doesn't fit on the site, right? Otherwise, 0. Watch node. All right. We're good. I've got stuff set as an output. I've got one more piece I'm going to do. I'm going to take all of these, combinify them, watch once more. Sum. Whoop. Come on, Jacob. Hit the right arrow. There we go. Is output. Overall score. 20 minutes left and I've yet to get into generative design, but guess what? We're there. So once you've installed the generative design package correctly, you should have this menu up in the top. We can go ahead and click on that and then we can say open generative design tools. When we do, we'll get a little pop-up like this. Again, it will look different depending on which version of generative design you're using. I'm using, I think, 22.10, but don't quote me on that. Give your graph a description. Keep your cache data. If you don't keep your cache data, the stuff that's in your remember node will go away. We want to keep those, so we'll go ahead and keep that. Do we want to include the file dependencies, the custom nodes? Yeah, probably makes sense to keep the custom nodes that we might have used. I don't think I used any. Let's actually double check. Monocle, package usage, doggy. Generative design is the only one. Don't need to worry about that because generative design will have the generative design nodes. So I did manage to do this without. We can then do an image. Does everybody know this little button, export workspace as image? My favorite button in Dynamo. It will take a snapshot of every node on canvas if you're in this view. But a lot of people don't realize if we go into our background preview and then use that button.
No way. Dana, did you know that?
I honestly never really mess with geometry in Dynamo. Like
okay.
usually if I'm messing with geometry in Dynamo, it's like specifically to push it to Revit, right? Like to place families in the room, right? So it's
Right.
like I'm looking at Revit in the background. I usually turn the previews off in Dynamo. But I will say, does it, or ask more, does it still matter like the zoom level that you take the picture in? Because I feel like with the overall canvas, not the 3D background, I'm not sure about the 3D background, you kind of have to be zoomed in for the clarity of the PNG to come out.
Yes, yes. So you want to zoom in before you use that because the export canvas as image, it gets everything, even the stuff that's not on canvas. With the geometry preview export, it's just exactly what you see.
Interesting.
You can see
right?
it there in the background.
So noted.
Yeah. So now that
could
we've got
be really
that,
nice for the previews, not only in generative design, but now within Player.
Yeah.
Correct.
Right.
With the new features in Dynamo Player for the 2023 product line. I like where your head's at, Dana.
Mm-hmm.
All right. So now we've set our image up. We've set this as a live demo. I hit go ahead and create study. I hit OK. And then I could go in and say generative design, create study. And when I did that, it would pop up this little tool here, which I already have open. And you're going to want to go ahead and add in a folder to wherever your graph was sort of saved. You notice I've already sort of put mine in there, right? And then once there, you can see this is the live demo, and this is the pre-baked one that I had sort of built before. And we're going to do a quick run through of what all these different settings mean. So first, I'm going to sort of collapse everything, right? Now I'm going to start with sort of the initial settings. Set this to live run. Method, we could do like this, randomize, optimize, or cross product. We're on optimize right now. Look at this list. If I go to randomize, notice I have less options. If I go to like this, similar to randomize. If I go to cross product, even less. So with cross product, you get to choose how many variations evenly split between the low entry point and the high entry point for all of our variables. I have a lot of variables here with 2 options per. This is 65,536 studies, 2 options per variable. Your mind, when you're a designer trying to decide where to set stuff up, is thinking through all of these and more, right? That's the power of this tool. It's going to sort of help you sort of do that initial trace sketching. It's not making the decision for you. It's giving you the ammunition to make the right decision faster. All right. So from here, the next setting to look at is issues. No issues. Next piece. We're going to skip over optimize for now. We're going to go to randomize. We can choose a setting to either randomize or not. If it's not randomized, we can choose what value we want it to have for all of my different variables. And then under generation settings, we can choose how many solutions we want to generate. I'm going to go ahead and I'm going to generate 40 solutions as long as there's no issues. There aren't. This seed value is just controls what method of optimization. So when I hit generate, we're going to get 40 random options that are going to just instantly populate. I say instant. But remember, it's going to spin up 6 instances of Dynamo Sandbox concurrently, so we can't see them. Let's go ahead and let's have a look at my task manager just to confirm. We're going to go to the details tab of task manager, and then we should start to see in here, if I sort by CPU is a good thing to sort by, rest Dynamo core. Oh, up.
Too late.
Too late, right? It happens fast once it gets all stood up. And then once that populates, you can see I've got a geometry preview, and this is just randomly throwing spaghetti at the wall, what stuck, right? So I'm sorting right now by tree score. I could sort by overall score. This is the best overall score. And hey, those buildings are pretty far apart. They miss almost all of the trees, and they're pretty close to site, but not really, right? So thoughts there. I forgot to actually mark the fit as an actual score as well as one of my other variables, but that's fine for now because I've got another sort of piece. And if I want to create another study, we can hit that button. And of course, every time I do, it's like, hey, you must want to see something else. So I have to minimize everything and then go back to generative design because, come on, where are you? There it is. All right. So, whoop, wrong piece. We're going to keep working with the live demo for now, even though it's not quite right. So we did randomize. Like this is just like randomize, only it's only going to move stuff by 10% of the overall domain. So 10 to 50, 40 possible variables. 10% of 40 is 4 up or 4 down for all my different sliders. Right? And it'll do that sort of randomly, but it's more of a controlled random sampling because the designer gets to choose where we start, right? I'm not going to go ahead and not going to run those, but we are going to look at optimize. So I forget who it was who had mentioned, sort of asked about the setting. I'm scrolling through the chat. Aramede, I'm sorry for getting your name wrong. I'm doing the best I can. The way the genetic algorithm works, we choose which variables we want to change. Right? Turn them off or on. If we want a constant variable, we can do that. Then we're going to say, what goals do we have? What do we want to do? Do we want to minimize values or do we want to maximize values? I try to always minimize. So we're going to set that to minimize. And then what do we want our separation score or, turn stuff off or on from there. But if we wanted to maximize, we could click that. Then from there, we set our constraints. I do not recommend playing with constraints until you get much, much further along in your sort of studies within generative, because effectively what this is going to do is if a result comes back, which is outside the range that you specify, it doesn't count and it tries again. So you can imagine within that large number, 65,000 possibilities for just the inputs on this study, right? What number of those are going to have values in between whatever you think might be ideal? It's a small number, right? So why not let the generative algorithm sort of explore the space on its own? There are some instances where you might want to use constraints, but for now, skip them. And then we get into our generation settings. First setting is population size. Every generation has a set population. The population must be divisible by 4. So if I say 20, it will take 20 samples for each generation. At the end of the generation, the generative design server is going to use the NSGA algorithm to say, what were my results? What is the, say, top 25% of all the results I've seen? Let's use those to inform the next generation. And it will do that for however many generations I set. So a 20 by 10 generation would look something like this. And I'm not going to see any results until the first generation completes. Before, when I did random, I saw 0 out of 40. Now I'm seeing X out of 10, right? So it's already run 160 different tests, right? And we're looking at tree score, and this is the best performing for the tree score where I only missed 1. But if I was to look at, let's say, overall score, right? This is my best performing for my overall score. Yeah, that doesn't look too great. Things aren't really great, but I didn't have a very large generation. If I do another study with the full graph that I sort of, again, pre-baked, it's a cooking show. We get to do this. One last live run on optimize. I can do a quick 20 by 20 study. Actually, let's set this bigger. Let's set the population to 100 by 20. So we're going to take a sampling of 100 random values. look at the best 25% of those and use that to inform the next 100. Right. And again, the computer's doing all this work while this is happening. Back when I was practicing, I'd set something like this up to run and I'd be like, I'm going to go grab myself a cup of coffee, or hey, it's time for lunch, or you know what, let's let this run overnight. Right. And so these things can go ahead and they can just bake, right, for whatever time period we might want. Now, while this bakes, you can sort of evaluate kind of what the outcomes look like up here. Notice each run, it's calculating new geometry. These geometries are actually live three-dimensional pieces. It gets really bold when I click it because it's sort of regenerated that as navigable space. That's right. This is a 3D view. I can zoom in. I can pan. I can orbit as I might desire. I've got a list of all my outputs here in my details tab as well, right? So I can see what my overall score is, what my tree score, fit score, separation score, et cetera, what my input values are. And I can also sort of quickly toggle between those different values. The other way to view this upper panel here is to look at it in list view. So we can go here and just see all our raw data. And if we pan over to the right, you can start to see what those input values were as opposed to the output values. And then I've got this area down here, which is our charts area. We can look at the scatter plot, where we can choose what value we might want to put on the y-axis, what value we might want to put on the x-axis, right? Tree score, probably not great. Let's look at tree score, fit score. We could put different value for the size. Let's put the overall score, and we can look at, let's say, the color. I don't know. Size score, there we go. So multiple ways to sort of explore that. And we can also filter this through. So let's look at, right now on my y-axis is my tree score. Let's limit what I see up above to just options that have a good tree score, right? And everything that shows up here now has tree score of 0, right? If I clear that filter, there's a tree score of 10, there's one of 20, right? And once I apply one of those filters, we can change that axis to look at overall score. Let's look at just stuff with an overall score. Actually, let's filter by just stuff that has, I forget what I have here, fit score of 1,000. And let's change that to overall score on that axis and look at just stuff that is in this range here. Just sort of quickly slice and dice. And again, this is all live. We're looking at it kind of in-dimensionally concurrently. Now, in the interest of time, again, cooking show, I'm looking at the clock. I've got 4 minutes left. I did a 100 by 100 study before we left, or before we started. And you can see here what this came up with. It would be really hard to put two buildings much further apart than this on that site. Look how magically I use does intersect as opposed to distance to. Look how magically that addition just sort of pokes out there right beyond that tree and just happens to magically hit that fit. If I was designing this by hand, I might say, let's put a mass that sort of aligns to that edge, just like that. So the computer can start to help us make those informed decisions. And you can see as I sort of navigate through here, there were some incremental improvements. Putting it here gets me a slightly different variable than there. If I shape my building a little bit differently, I get still different results, so on and so forth for all the different sizes and all the different shapes that I might have. So you can get some really good sort of introduction. There is a question here in the chat. Would you say the advice applies across all generative design processes? If you were using Fusion 360 for another use case in terms of constraints, constraints in Fusion 360 are very different from constraints in generative design for AEC, the generative design Revit sort of tool set. Constraints in Fusion 360 are basically going to say, hey, here's where we can't put stuff, right? And that's going to sort of inform the topological optimization or the tool pathing that is used to sort of define that shape. Cool. Well, 4 minutes left. We're on to the question slide. Oh, and of course, my display settings are backwards because Zoom update.
Yes, of course.
That was not the button I wanted to hit.
So what time is it over there?
Right now, my clock says 7:30.
Oh, okay. I thought it would be
It's
later.
not 7:30. I keep the East Coast time when I travel.
Ah.
All right, I'm going to stop share once more. I'm going to go back to PowerPoint because clearly I did something wrong here. Show presenter view. There we go. Display settings. Swap. And that was the button I was looking for. And we're going to share once more all of screen one. So I don't like to send people off into the woods for something that's hard without a quick run through some resources. Dynamo's main home on the web, dynamobim.org, for all your Dynamo information and news. In particular, check out the blog at dynamobim.org/blog. That is where the news hits first. Sol and the Dynamo team put a lot of work into sort of maintaining that and letting you guys know what's coming. Remember, Dynamo development happens much faster than Revit development. In fact, we talked about 2.13 being new today in terms of what came out with the 2023 product line. Well, guess what? 2.14 is already out with all sorts of great bug fixes for the stuff that we found in 2.13. Make no purchasing decisions. DynamoBuilds.com is your source for installing different flavors of Dynamo. So if you wanted to get your hands on Dynamo 2.14, you can do that there. And you can also get involved with the development team directly at the Dynamo GitHub, github.com/dynamods/dynamo. There's also a Dynamo Revit repository if you want to get involved with the Dynamo Revit team, suggest some cool new nodes and stuff like that. Some great resources for learning Dynamo are available at the Dynamo Primer. Primer.dynamobim.org has a series of great guided examples that you can sort of move through, as well as always point people out to the forum at forum.dynamobim.com and our Dynamo dictionary, dictionary.dynamobim.com. Spoiler alert, that has been incorporated into 2.14. So you no longer have to go to the web to find out how a node works. This is awesome. I love it. All right. DynamoNodes.com is a sister library of sorts that shows you how to work with particular custom nodes. Some resources for design script are given on the lower left-hand corner there. Dynamo Python in the upper right-hand corner. We didn't talk about that at all today, but it is super useful. And then last but not least, generative design. That's what we're here to talk about after all, right? Info on generative design can be found at autodesk.com/campaign/refinery beta. If you want to get involved with the beta site, that's at feedback.autodesk.com/key/refinery landing. And last but not least, it's in the middle of the bottom there, is the generative design primer at generativedesign.org. All sorts of great resources for getting started with this kind of content. Take the time to sort of run through them. And then last but not least, we've got our Customer Success Learning Hub at customersuccess.autodesk.com. Access to all sorts of great articles, tips, tricks, product updates, and a great community of users just like you guys. That's again, customersuccess.autodesk.com. Who's got questions?
Well, you had a
Do
wonderful.
you memorize those links?
I
Can
know,
you say that
seriously.
in your sleep?
I know, that's impressive. Yeah.
Kind of.
I think you could. I think you could.
You should look in the chat. You had a wonderful comment from Giancarlo. Not sure if I'm saying that right, but it's he just was just gushing over your teaching style. So I agree completely with everything he said, but I just definitely wanted you to read that before you log out. So
thank you. That's actually really touching. It means
Yeah.
a lot. So thank you, Giancarlo.
Hey, that's all awesome. So you choose the sandbox for simplicity, or because there's things you can do there that you can't do in Dynamo for Revit or one of the others? What's
So the biggest advantage to Sandbox is multi-threading.
Okay.
Everybody's biggest knock on Revit, right? Why does it only use one processor? There's a lot of really valid reasons, and it's not single processor, right? But with Dynamo, in particular in the Sandbox environment, you can use one thread to work on your geometry display and another thread to work on your mathematical calculations. So I can be navigating a graph while it's executing. You cannot do that in Dynamo for Revit, Dynamo for Civil, Dynamo for any of the sort of direct integrations. Dynamo to Format you can, Dynamo for Alias you can. I think those are the only two sort of discrete integrations right now. And so as a result, if I notice it's crashing, I can usually hit save before it actually dies, which is why I wasn't too worried about, hey, Jacob, you might want to save earlier. Still great advice. once every 15 minutes at a minimum. Please sync your Revit models. I hate when I hear, oh, we lost a day's worth of work.
Yeah.
It's really painful. So, cool.
Wow. All right. Well, thank you so much, especially now that I know you're there in the middle of the night across the world. That was much appreciated. Thanks for joining us. And you're definitely welcome anytime. So if you've got something new to share, we would love to have you in the future. So
yeah, absolutely. I'll keep you guys in mind. And if there are any other topics you want to know about, feel free to reach out.
Will do. All right. Well, thanks everyone for coming. We did get up to about 10 there for a while. So, I don't know if you were watching, but yeah.
They were good numbers. I was happy with it.
Yeah. All right, great. All right. Well, I will process the recording and get it posted on our YouTube channel, and I'll send you a link when it's done. So,
cool.
All right.
Thanks, everybody.
Good seeing you, Dana. Thanks for coming.
Great work, Jacob.
Yeah, I owe you an email, Dana.
No, I didn't realize that you had this today. I'm sorry. I don't keep into my notifications as well, but luckily I got a private notification by my good friend Paul.
Yeah.
Awesome.
But actually, I also have some updates on some of the material workflow that I was talking to you about.
Oh, yeah.
And
let's
pushing in some finish elements into the finished documentation stuff. So no more filled regions, no more text. So maybe we could do a joint ChiNamo sometime soon on that.
I'm in.
All about it.
You guys let me know when you're ready. Yep, I love it.
Cool.
Okay.
All right.
Awesome. Well, yeah, go get to bed.
Yeah.
Yeah, I got to go pack. I've got a flight.
There you go. Well, it's almost 8 here in DC, same time zone, and it's still kind of light out. So you have that to look forward to. Well, I'll talk to you both later.
All right.
And everyone else on the call.
Yeah, sounds good. Thanks a lot.
Bye.
Thanks again, Paul.
You bet. Thank you. All right, I'm going to stop recording now.